Okay, in this lecture, we are going to study about derivatives of inverse hyperbolic functions. So we'll pose them in form of questions. So one, given that y equals to find dy dx. So y is this inverse of hyperbolic sine. So the question is to find the derivative of this function. So this one is not a very hard problem to solve. So solution. So you change from being an inverse hyperbolic function to just being a normal hyperbolic function. So note that y equals to hyperbolic sine inverse of x is the same as saying x equals to hyperbolic sine of y. So therefore we have this function. Hyperbolic sine of y is given by x. So the next step, you introduce d dx on both sides. So you say d dx of hyperbolic sine of y is given by d dx of x. Now we know that when you differentiate a hyperbolic sine, you get a hyperbolic cosine, but then this y is assumed to be a differentiable function of x. So therefore, the solution here, d dx of this function will be hyperbolic cosine of y, but then you attach dy dx. So this is the implicit differentiation, equals to d dx of x is just 1. And then we are interested in finding dy dx. So dy dx will be given by 1 over hyperbolic cosine of y. But you don't stop here. Remember, our derivative must be in terms of x. And not y. So therefore now we need to look for a way of re-expressing the cos, hyperbolic cos of y to be in terms of x. So this is we achieve this one by remembering this identity, but that hyperbolic cosine of y minus hyperbolic sine of y gives us 1. This square. Then the square of hyperbolic cosine minus the hyperbolic sine gives you, that difference gives you 1. So don't forget this identity. So from this one, it's clear that hyperbolic cosine squared of y will be given by 1 plus hyperbolic sine squared of y. So which tells us that now then to get hyperbolic cosine alone of y will be given by the square root of 1 plus hyperbolic sine squared of y. So therefore, from this one here, we have dy dx will be given by 1 over, so where this hyperbolic cosine of y, we write it as the square root of 1 plus hyperbolic sine squared of y. But remember from the start that hyperbolic sine of y is given by x. So which means that then when you say hyperbolic sine of y squared is given by x squared. So therefore, dy dx will be given by 1 over the square root of 1 plus x squared, or just the same as 1 over the square root of x squared plus 1. So that is what we have. And then given y is hyperbolic, inverse hyperbolic sine of x, hyperbolic cosine of x, dy dx is given by what function? So in a similar fashion, you say solution y equals to hyperbolic cosine inverse of x is the same thing as saying x equals to hyperbolic cosine of y. And then you arrange it as hyperbolic cosine of y is the same as x. So this new function without inverse, you now supply d dx on both sides. So d dx of hyperbolic cosine of y equals to d dx of x. Now this will give us, when you differentiate hyperbolic cosine, you get hyperbolic sine, but you attach dy dx because this y is a differentiable function of x. Remember implicit differentiation, and then this is 1. So therefore dy dx will be given by 1 over hyperbolic sine of y. But you don't stop here. Remember that the derivative must be in terms of x, not y. So also remember that hyperbolic sine squared, hyperbolic cosine squared of y minus hyperbolic sine squared of y is 1. So from this one, hyperbolic sine squared of y will be given by hyperbolic cosine squared minus 1. So which tells us that then hyperbolic sine of y alone will be the square root of hyperbolic cosine squared minus 1. But remember from the word go, hyperbolic cosine of y is x. So when you square it, it becomes x squared. So therefore this question becomes dy dx equals to 1 over, so instead of writing hyperbolic sine of y, you write square root of hyperbolic cosine of y squared minus 1. So which will be given by square of x squared minus 1. And then you give the condition that this x must be greater than 1 for this fraction to be defined. So therefore, that's the solution for the derivative of the inverse of hyperbolic cosine of x. And then let's do for the tan. So given that y is given by the inverse of hyperbolic tan of x, find dy dx. Also, what you do, you change the function to be just in terms of the normal hyperbolic function, not the inverse. So this is the same as saying that x is the same as hyperbolic tan of y. And then you write this one as hyperbolic tan of y equals to x. Now in this new equation, now you introduce d dx on both sides. So we have d dx of hyperbolic tan of y will be d dx of x. So which tells us that now when you differentiate a tan function, you get an sec, so the sec squared y dy dx equals to 1. And then we are interested in finding dy dx, so dy dx will be given by 1 over sec, hyperbolic sec squared of y. But you don't stop here. Remember, the derivative must be in terms of x. So this is how you now change this one in terms of x. So remember, that the square of hyperbolic cosine minus the square of hyperbolic sine gives you 1. So from this one, how do you get sec? Sec is obtained by saying 1 over cos. So therefore, in this equation, if you divide by hyperbolic cosine squared, so it will be 1 minus, so sine over cos gives you hyperbolic tangent. 1 over this gives you so, which tells us that then now this is what holds here. So therefore now you rewrite this equation as dy dx equals to 1 over. So instead of writing sec squared as hyperbolic sec squared of y, you write it as 1 minus hyperbolic tan squared y. But you remember from the word go, hyperbolic tan of y is given by x. So when you square it, it will be now x squared. So this will be 1 over 1 minus x squared. So therefore, dx of hyperbolic inverse of tan is given by 1 over 1 minus x squared. So here the absolute value of x must be less than 1, so that we don't get a 0 in the denominator. And then next, given y is hyperbolic inverse of cot, then dy dx is given by what function? So solution, we do the same thing. So we say, saying y equals to hyperbolic inverse of cot is the same thing as saying that x is the same as cot, hyperbolic cot of y. So we write that one as a hyperbolic cot of y equals to x. And then introduce d dx on both sides. So d dx of hyperbolic cot of y equals to d dx of x. So therefore, this will give us, when you differentiate a hyperbolic cot, you get a negative hyperbolic cos x squared dy dx by implicit differentiation equals to 1. And then this one will give us, so which means that dy dx will be negative 1 over hyperbolic cosec squared of y. But you don't leave your answer at this point here. You remember that the derivative must be in terms of x. So therefore, from this identity, recall hyperbolic cosine squared of y minus hyperbolic sine squared of y equals to 1. So to get cosec, we divide through by sine. So divide this one by hyperbolic sine squared of y, hyperbolic sine squared of y, hyperbolic sine squared of y. So this cos over sine will be cot minus 1 equals to, so this one will define cosec squared y. So which means that then now this derivative here so becomes dy dx equals to negative 1 over, so instead of writing cosec squared of cosec hyperbolic squared of y, we write as cot hyperbolic squared of y minus 1. But you remember that from the word go, we have hyperbolic cot of y is x. So therefore, this will be square. It's like negative 1 over x squared minus 1. So therefore, this is the function that defines the d dx. So therefore, d dx of hyperbolic cos inverse of x is given by negative 1 over x squared minus 1. But the same thing you can actually, so this like we have negative 1 over x squared minus 1, which is the same thing as saying negative 1 over, I can factor out negative 1, and then I have 1 minus x squared. Remember, this is the same as this, is the same as this. So therefore, this and this cancels out. So the same thing as saying d dx of hyperbolic cot inverse of x is the same as 1 over 1 minus x squared. And then, so, but for this thing now, absolute value of x must be greater than 1 for that one to be defined. So this is how we can as well write that same expression. So in summary, one, d dx of the inverse of sine hyperbolic is given by this. Number 2, d dx of inverse of x is 1 over the square root of x squared minus 1, and then x must be greater than 1. Number 3, d dx, you can always prove this, of inverse of tan hyperbolic is 1 over 1 minus x squared. Condition here is that x must be less than 1. Absolute value of x must be less than 1. Number 4, d dx of hyperbolic cot inverse of x is 1 over 1 minus x squared, which will be given by, or the same thing as saying negative 1 over x squared minus 1, and then x absolute must be greater than 1. Number 5, d dx of will be given by negative 1 over x square root of 1. So please prove this, where x should be between 0 and 1. And lastly, d dx of will be given by one over x squared plus 1. X must never be 0. So that is a summary on how to carry out derivative of inverse hyperbolic functions. Thank you.